So in this problem, we're trying to find a subarray product less than k. No, not just a, but a count of all subarrays less than k, given an array of integers. So, for example, let's take this. We can consider this subarray here, starting from I and j. So if I and j are like this, let's say that means we're only considering one number in our subarray so far. That's 10. The product is 10, which is less than 100, so that would count as 1. So our answer would be 1. This would also be a subarray less than 100, because that's only just 50. So I increment the answer by 1. This array by itself is also 1, so that's 3. If I move this back and move this here, that's 100. But less than k, not less than or equal to k. It has to be strictly less than k, so that doesn't count. This array also works, so it's like 4. This array also works, that's 5. This subarray works, that's like 6. This subarray works, 7. And finally, this subarray also works, it's 8, which is the answer. Okay, so that's like n squared, because there's n squared subarrays. But the number of integers in the array is up to 3 times 10 to the power 4. That's too large to do n squared on, so we're going to have to find a better solution than that. So let's see if we can optimize this process a little bit better. If we use a sliding window approach, we can find for any position of j, the maximum subarray ending at j that has a product less than 100. It's like, say for example, this by itself, 10 by itself, is the maximum subarray length ending at j that's less than 100. Then we can move j up. This is less than 100 still, so this is the max subarray length less than 100 for j at this position. Change it back to 02. So I can move this up, and then I see that this is 100, which is not less than 100, obviously. So because of the sliding window approach, I could just move I up, and now my product is 10, and this would be the max subarray length of a subarray of all subarrays of a subarray ending at 2, with j ending at 2. So let's try and increase that now, and that also works. That's 30, 60, right? So this is the max subarray length ending with j at this position. So we can find all the subarrays of max length ending at each position. It's just a matter of counting those individual subarrays, because for say for example, this subarray here, all subarrays ending at j is actually equal to 3. So you have this one here, you have this one here, and you have this one here. So just the length of the array. So every time I move j up, as long as the product is less than 100, I just count this length of that subarray every time, and then that will be the answer. So Let's give that a go. So you keep track of product, starts at 1, and you also want to keep track of I, which starts at 0. And our j would go from 0 and j less than k, I think. Plus j. Not k, sorry, this is nums dot length size. And basically we have to multiply a product by the nums at j, and we want to check if the product so far is greater than k. If it is, then I want to increment I. Okay, so there may be the case where, say for example, I have say 50 here. So let's move j up here, and then now suddenly that's like way larger than anything I want. So that's like 60 times 50, 3,000. So once I move j up here, to get to a position where to get the subarray, the max subarray length ending at j to have a product less than 100, I have to keep moving I up until that is the case, and that would be up to here. So I need to do that in a while loop instead. So while I is less than j and the product is greater than or equal to k, I want to do plus I. And also, if I'm doing that, that means I need to divide the product by, divide the product by I before I increment it. So I want to get rid of that from the product. And then I want to add to the answer. Answer is equal to 0 initially. At this point, either the subarray, either prod is less than k, which means I need to count to add to the answer, or prod is greater than the answer, because either way prod could be less than or greater than or equal to k. So I need to check if the product is less than k, then I can add to the answer. So answer plus equals to j minus I plus 1. So that's the length of the array. And then just return the answer. So that's 8. Okay. Let's give this one a go. Actually, let's give this a go. Wait, let's copy that. How did they do it before? Okay, so you have to put it in square brackets. Okay, I think that works. Awesome.